Ever wondered how to efficiently combine data from multiple tables in SQL? Today, we're going to unravel the magic of SQL joins and how they can transform your data analysis skills. Welcome back to the Knowledge Academy's YouTube channel. Today, we're diving into one of the most powerful features of SQL, that is joins. Whether you're querying data from multiple tables or combining datasets, joins are essential. So let's get started. First, let's understand what joins are. In SQL, a join is a means of combining fields from two tables by using values common to each. Joins allow you to retrieve data from multiple tables based on a related column between them. Joins are incredibly powerful and enable you to perform complex queries across multiple datasets. Imagine you have two tables, Table A and Table B. A join operation allows you to merge these tables based on a common column, producing a single result set that contains columns from both tables. The common syntax used for joins is written as: select then the column names, which are generally written with aliases as a .column name and b.column name. Then in from we write table name and give it aliases like table 1 as A. Then we write the type of join which we are using, and then the name of the table on which we are joining, like table 2 as B. Here for second table, we gave the alias as B. Then after that we write on. Here we specify the name of the column from two tables on which we are joining the table as A. The column name equal to B. Column name. Now let's look at the types of joins in SQL. There are several types of joins in SQL, each serving a different purpose and retrieving data in a unique way. Let's see how many joins there in SQL are, and then we will learn about it in detail. SQL has inner join, left join or left outer join, right join or right outer join, full join or full outer join, cross join, self join. Now let's understand each of them in detail along with an example. But first, let's look at some tables which we will be using in this video for examples. We will be using books and authors table in this video. Link to these datasets is given in the description below. Now let's quickly import these tables in our SQL Workbench one by one. If you want to know more about how datasets can be imported in Workbench, then you can watch our previous videos on how to import datasets in SQL. Link to the previous videos is mentioned in the description below. Let's quickly see the contents of all the three tables which we are using. For that, we will write the simple query of select asterisk from books table. Here you can see the column names and the data. Likewise, we will see the contents of the other table. Now let's begin. First is inner join. An inner join returns records that have matching values in both tables. It filters the result to include only those rows where there is a match in both tables. Inner joins are used when you want to retrieve data that exists in both tables. Let's understand this concept with an example. Suppose we want to join the books and authors tables to get the book titles and the corresponding author's first and last names. An inner join is perfect for this because it will only return the rows where there is a match in both tables. For this, we will write the query as select d.title, then a.first name and a.last name. Here the A and B that we used are aliases for the table which we are referring to. You can use table name directly, but using aliases makes the job easier. Then from books table, give it alias as B. Then we will write inner join and give the name of the table with which we are joining the other table. Here it is authors table, give an alias to this table as well. Here we are taking it as AE. Now write on and specify the columns of both the tables on which you are joining. Here it's b.author ID equal to a.author ID. This is crucial here. It tells SQL to match rows in the books table with rows in the authors table where the author ID values are the same. Let's execute this query. You can see we are getting names of the books which have author's first and last name. Now let's see the next type of join. Next, we have the left join. A left join returns all records from the left table and the matched records from the right table. If there is no match, the result is null from the right side. Left joins are useful when you want to retain all records from the primary table and see where matches occur in the related table. Let's understand this with an example. Suppose we want to retrieve a list of book titles along with the corresponding author's first and last names. If a book does not have a matching author in the authors table, the book title should still be included in the results, but with null values for the author's first and last names. For this, we will write the query as: select then right desired column name, here it is b.title. As B, we will be taking alias for books table. Then write a.firstname. We will be taking A as aliases for authors table. Then a.lastname. Then in from, we will write the table name. Here it is books and give it an alias as B. Now use left join as you want all the data from left table and the common data from right one. Then write the table name. Here it is authors table, give it aliases as A. Then write on and provide name of the column on which you are joining it. Here it is b.author_id equal to a.author_id. Keep this in mind that the column of the table which you write first after writing on is the table which is considered in the left, and then next one is considered as right. Here the books column is referred first after on, therefore the books column is the table in the left and authors table is in right. This position depends on your requirements. You can change it according to your need. This query will return all books, along with their author's details if available. If a book has no matching author, the author fields will be null. Now let's execute this query and see what we are getting as output. In this output, even if a book doesn't have a corresponding author in the authors table, it will still be listed, but with null values for the author's name. This is useful when you want to retain all records from the primary table and see where matches occur in the related table. Now let's move on to right join. A right join is the opposite of a left join. It returns all records from the right table and the matched records from the left table. If there is no match, the result is null from the left side. Right joins are useful when you want to retain all records from the secondary table and check for matches in the primary table. Let's understand this with the help of an example. Suppose you want to retrieve a comprehensive list of all authors along with the titles of books they have written. If an author does not have any books listed in the books table, the author's name will still be included in the result, with null values for the book titles. So for this we can write the query as select b.title, then a.firstname, then at last a.lastname, same as the left join. From books as B, then write right join, then the table name you want to join, here it is authors as A. Then write on, after that write, b.author_id equal to a.author_id, same as we did in left join. This query will return all authors, along with their book's details if available. If an author has no matching book, the book fields will be null. Execute this, and you can see we got the desired output. Here, all authors are listed, and for authors without a matching book, the book title will be null. This type of join is useful when you want to see all records from the secondary table and check for matches in the primary table. Now, next is the full join. Full join returns all records when there is a match in either left or right table. Records that do not match in either table also included with nulls in places where there is no match. Full joins are useful when you need a complete dataset from both tables, regardless of matching records. Let's look at an example to understand this in a better way. Suppose we want to retrieve a comprehensive list of all books and all authors, ensuring that no data is left out even if there is no direct match between books and authors. But in my ESQL, the full join or full outer join syntax is not supported, so for full join we use union. For this you can write the code as write select and name of the column, that is b.title, then a.firstname and a.lastname. From books table as B, then write left join, then the table name with which you want to join it, here it is authors as A on columns b.author_id equal to a.author_id. Now write the union, and then again write select, then name of the column, that is b.title, then a.firstname and a.lastname. From books as B, then write right join, then the table name authors as A, then on, after that write b.author_id equal to a.author_id. In this code, the first part uses a left join to get all records from books and the matching records from authors. Then the second part uses a right join to get all records from authors and the matching records from books. Finally, the union combines the results from both joins, ensuring that each unique record appears only once, effectively mimicking a full outer join. This approach will provide the complete set of data from both tables, including records that do not have matches in the other table. This query will return all books and all authors, with nulls where there is no match. Now execute this code and you will get a comprehensive table with all the data. This output includes all books and all authors, filling in with nulls where there are no matches on either side. Full join is useful when you need a complete dataset from both tables regardless of matching records. Now let's learn about cross-join. Cross-join returns the Cartesian product of the two tables, meaning it returns all possible combinations of rows from the tables. Cross-joins are less commonly used but can be very powerful in the right context, especially for generating combinations or permutations. Let's take up an example to understand this. Suppose we want to generate a comprehensive list that includes every possible combination of book titles and author names, regardless of any direct relationship between them. The goal is to create a Cartesian product of the books and authors tables. Query for this can be written as: select then name of the column, that is b.title, then a.firstname and a.lastname. From books table as b, then write cross-join authors table, and that's it. This query will pair each book with every author, regardless of any logical relationship. Execute this code, and you can see a comprehensive table with every possible combination. As you can see, every book is combined with every author, resulting in multiple rows. Cross-joins are useful when you need to explore all possible combinations between two tables. Now last, but not the least, is self-join. A self-join is a regular join, but the table is joined by itself. This is useful for comparing rows within the same table. It's a great tool for hierarchical data or comparing records within the same dataset. Let's understand this in a better way with an example. Suppose we want to find books that have the same author but are different books. We can use a self-join on the books table to achieve this. Select the title column from the first instance of the books table with alias A and label it as book title. Select the title column from the first instance of the books table with alias B and label it as book title. Now select the title column from the second instance of the books table as alias S and labels it as related book. This means the result will have two columns, book title and related book. Specify the books table as the primary table and assign it an alias B, then write join. We don't write self-join for this. Instead, we write join only, which is basically inner join on the books table with itself, using an alias S for the second instance of the table. After that, in the same way as we had written before, write on, and then the columns b.authorid equal to s.authorid. Now adding a where condition as b.authorid is not equal to s.authorid. This ensures that we are looking at books that share the same author ID, meaning they are written by the same author. Conditioned with where clause is shown is to ensure that the joined books are not the same book. The ID column is the unique identifier for each book. This filter ensures that each book is paired only with other books by the same author that have a different ID. In this query, we're selecting the title from the books table twice, but we're treating it as two different instances, that is, B and S. The condition for the join is that the author ID in instance must match the author ID in instance B, and we add a condition to exclude cases where the book IDs are the same. Let's execute this and see the result. You can see that the query retrieves pairs of book titles where the books are written by the same author but are different books. This is achieved by self-joining the books table on the author ID and ensuring that the ID of the books in each pair is different. The result is a list of book titles with their related books by the same author. Now here is a question for you. Which type of SQL join returns all records from the left table and the matched records from the right table, with the result being null from the right side if there is no match? A. Inner join. B. Left join. C. Right join. D. Full outer join. Write your answers in the comments section below. And that's a wrap on SQL joins. Understanding these different types of joins can significantly enhance your ability to query and manipulate data efficiently. Next in this SQL playlist, we will learn how we can join multiple tables in SQL and also about equi and non-equi joins in SQL. Stay determined to learn this powerful skill of SQL, and we will meet you in the next video. We'd love to hear your suggestions. Let us know in the comments which topic you'd like us to cover in our next video. If you enjoyed this video, hit the like button and subscribe to our channel for more exciting and informative content. Don't forget to turn on notifications so you never miss an update.